What you're about to witness is not a concept, not a prototype behind glass, and not a distant promise. This is the future being built, right now. Inside Tesla's advanced manufacturing facilities, a humanoid robot is taking shape. Not designed for spectacle, but for real-world utility. A machine built to walk among us, work alongside us, and eventually change how society functions. This robot is called Optimus. Tesla's vision goes far beyond electric vehicles. The company believes the greatest transformation of this century will not be transportation, but intelligent automation. Optimus represents Tesla's entry into a world where machines don't just assist humans, but actively replace dangerous, repetitive, and physically demanding labor. Unlike industrial robots locked behind cages, Optimus is designed for human environments, factories, warehouses, offices, and even homes. It walks on two legs, uses human tools, understands visual information, and learns through artificial intelligence. But building a humanoid robot at scale is one of the hardest engineering challenges ever attempted. To understand how Tesla is doing it, we must go inside the production line, where raw materials become intelligent machines. Every humanoid robot begins the same way a human does, with a skeleton. At Tesla's production facility, the Optimus frame is assembled from high-strength, lightweight alloys designed to handle extreme stress while remaining agile. Engineers must achieve a delicate balance, strong enough to lift heavy objects, yet light enough to walk naturally. Unlike traditional robots, Optimus does not rely on bulky external structures. Its frame is compact, human-proportioned, and internally reinforced. Each limb is engineered with precise tolerances, ensuring perfect alignment for joints, motors, and sensors. The shoulders, hips, knees, and ankles are among the most complex areas. These joints must allow a wide range of motion while maintaining stability and balance. Even a fraction of misalignment could affect how the robot walks or whether it can walk at all. Advanced robotic arms and automated systems assist technicians during assembly, but human oversight remains critical. Every frame undergoes structural verification, ensuring it meets Tesla's strict performance standards. This skeleton is the foundation of Optimus. Everything else, movement, intelligence, and autonomy, depends on it. Movement is what transforms a machine into something lifelike. Instead of traditional motors, Optimus uses custom electric actuators designed by Tesla. These actuators function like artificial muscles, converting electrical energy into smooth, controlled motion. Each limb contains multiple actuators working together, coordinated by advanced control algorithms. This allows Optimus to walk, turn, squat, lift objects, and maintain balance on uneven surfaces. Hands are among the most complex components. Each finger contains multiple degrees of freedom, allowing precise gripping and manipulation. From picking up delicate objects to handling tools, these hands are designed for versatility, not brute force. Tesla's experience with vehicle drivetrains and electric motors gives the company a major advantage here. The same principles that allow electric cars to accelerate smoothly are now being applied to humanoid robotics. Once assembled, each limb undergoes movement calibration. Engineers test speed, torque, responsiveness, and energy efficiency. The goal is natural motion, not robotic jerks or mechanical stiffness. This is where Optimus begins to feel less like a machine and more like a being. A humanoid robot that cannot see or think is useless. Optimus is equipped with an advanced sensor suite, including high-resolution cameras, depth sensors, force sensors, and inertial measurement units. These components allow the robot to perceive its environment in real time. The cameras feed visual data into Tesla's neural networks, the same AI architecture used in Tesla's self-driving cars. This enables Optimus to recognize objects, understand spatial relationships, and navigate complex environments. But vision is only part of intelligence. Optimus constantly processes feedback from its joints and sensors, adjusting movement dynamically. If it slips, it corrects. If it encounters resistance, it adapts. If the environment changes, it recalculates. This is real-time AI decision-making. Tesla trains these neural networks using massive datasets and simulation environments. Over time, Optimus improves, not through manual programming, but through learning. This ability to learn and adapt is what separates Optimus from traditional robots. It is not prescripted. It evolves. And that evolution happens at the core of its intelligence systems. Intelligence and movement require energy. Inside Optimus is a compact, high-density battery system derived from Tesla's electric vehicle technology. This battery is optimized for long operational life, fast charging, and safety. Unlike vehicles, Optimus must distribute power across dozens of systems simultaneously: actuators, sensors, processors, and cooling systems. Tesla's power management software ensures efficient energy usage, maximizing uptime. At the heart of the robot is its control computer. This system acts as the brain, coordinating movement, vision, decision-making, and communication. Advanced cooling systems prevent overheating during continuous operation. Every component is designed for reliability, because downtime means lost productivity. Before final assembly, power systems undergo stress testing, simulating long workdays, heavy loads, and unpredictable conditions. Only after passing these tests does Optimus move to the final stage. This is where theory meets reality. The final stage is validation. Optimus enters performance testing environments where it must prove its capabilities. Walking test, object manipulation, balance recovery, task execution. Engineers observe every movement, logging data and making fine adjustments. AI models are refined. Motion parameters are optimized. Once approved, Optimus is ready for real-world deployment. Tesla envisions these robots working in factories, warehouses, and logistics centers, handling tasks that are repetitive, dangerous, or physically exhausting for humans. But this is only the beginning. In the future, humanoid robots like Optimus could transform entire industries: healthcare, construction, agriculture, and even domestic assistance. What we're seeing today is not just a robot being built. It's the foundation of a new era. An era where intelligent machines walk beside us. And the future is already online. What you've just seen is more than a factory tour. It's a glimpse into the next chapter of human history. From precision-engineered frames to intelligent actuators, from AI-powered vision to self-learning neural networks, Tesla's Optimus is not just being assembled, it's being born. Every component, every line of code, every test brings us closer to a world where humanoid robots are no longer science fiction, but part of everyday life. Optimus represents a future where machines take on dangerous, repetitive, and exhausting tasks, freeing humans to focus on creativity, innovation, and purpose. This isn't about replacing humanity. It's about redefining what humans can achieve when technology works alongside us. Tesla's approach shows us something powerful: the same AI that drives cars, the same batteries that power electric vehicles, and the same automation that builds at scale are now converging into a single intelligent machine. A machine designed to walk, learn, adapt, and evolve. And this is only the beginning. As humanoid robots continue to advance, the question is no longer if they will change the world, but how fast. Factories, logistics, healthcare, and even homes may soon see intelligent assistants operating seamlessly in human environments. Here on Seaboy Tech, we don't just watch the future, we break it down, analyze it, and bring it straight to you. If you're excited about AI, robotics, and next-generation technology, make sure to like, subscribe, and turn on notifications so you never miss what's coming next. The future isn't coming. It's already here. Welcome to Seaboy Tech.